Okay, in the last video, we defined list, tuple, set, and dictionary, and we actually access different values. In this video, I'm going to actually introduce more indexing, how to access list and tuple, in particular because they both are very easily indexable, like strings. And I want to show you that all kind of indexing that you have seen in strings exactly works in list as well as in tuple. So let's go to Jupyter and see what a list is. For example, a list, if you print a list, that's a list. It has these kind of values. If you just see the list, for example, starting from index 1, ending at index 3, that means the same. Pick a slice, for example. So index 1 value is 3, index 2 value is 4.9, and the last element is not included. So if you get that, you get 3 and 4.9. So exactly the same kind of indexing that you have seen in strings, exactly that is working here as well. So for example, if I say list, start from the beginning, go to end, but then I just give -1, it will reverse the whole list. I mean, the whole list will be reversed. I mean, all the things that we saw in string, the indexing stays exactly the same in list as well as in tuple. So tuple, for example, let's access element from let's say from the very beginning till the third element. That's not the third element, till index 3, which is actually the fourth element. So tuple and list, they will be exactly indexed as it is. So all the slicing, all the indexing, all the sub listings, all the subtuples, they can be accessed exactly the same way as you've gone through the string. One difference here that I will explain later on, because a list is mutable, it is changeable. I will discuss one thing, that when you slice it, when you get a sublist, then actually it refers to the same memory, and if you change the sublist contents, the actual list got changes. That is true for list in slicing, and that is true for sets and dictionaries in the copying the references and so on. So I will discuss that later on, but rest of the things are roughly the same as they're in string. Indexing is almost the same everywhere in Python. It has this kind of slicing is almost the same. If you know the how to index strings, you know how to index lists. If you know how to index lists, you know how to index tuples and strings and everything. And by the way, if you know how to index string lists, you'll be very fluent in NumPy. That's the very powerful data structure. That's the very powerful kind of array processing package, with some differences that we will see, but um, even the indexing is same in pandas when you are working with large amount of data files and stuff like so. The indexing is more or less the same that you've seen in strings. We will cover indexing, masking, and fancy kind of indexing in much more detail in NumPy, but this stays the same as you've seen in strings. Okay, so now can we expand the list? Can we add more elements? Can we insert more elements to the list? The answer is yes, because list is changeable, mutable. You can insert more elements. One way of inserting that is just to call an add operator. You just add plus and you just insert another list. So like two strings are concatenated by plus, two lists can be concatenated or combined together again by plus. But there is a faster function called append, l.append, that is sometimes faster than using this operator. We will see that. Tuple, because it is immutable, you cannot touch any content of the tuple. You cannot actually insert any element to a tuple. You cannot delete any element to a tuple. There are workarounds, for example, convert a tuple to a list, change it, then convert the list to a tuple. There are ways to do that. But tuple in its true sense, in the literal sense, it is immutable. You cannot insert any element. You cannot delete any element. You cannot change any element. However, you can combine two tuples together. You can concatenate two tuples together again by plus operator and save the result into a new tuple. That's possible. Set, you can insert elements using an add function. Add function allows you to just insert one element. If you want to insert more than one elements, then you can call an update function that actually accepts more than one element, that accepts another set that need to be inserted. That's possible. Dictionary, you can insert a new key by just d, new key equals to that. You just assign a new value to a new key, and the key value pair is just inserted there. Great. You can delete or remove any element from the list using del command, del L1. That means this particular element is deleted from the list. That is possible. Deleting particular element from the tuple is not possible. However, you can delete the whole variable, whole tuple. That is possible. You can remove elements from the set using remove function, s.remove, and then you just give the element that you want to remove. That is possible. It will be removed. and you can delete the whole variable that is always available. Similarly, you can delete a particular item from the dictionary by just calling the D of the value, for example, whatever the key is. So you call with the key and call delete, and it will delete everything. I want to mention here, to remove items from the list, there are other methods and functions that are also available. That there is a remove function, there's a pop function. These are available. Similarly, from removing elements from the dictionary, there are other functions that are available. But just to compare them together, I'm using this del command, although there are other ways of doing the same stuff as well. So let's end this video here, and in the next video, I will show you all these operations that concatenating together, inserting more elements, deleting different elements. I will show you all these things in Python. So hope to see you in the next video.
So we're learning data structures. So let's practice some questions now. Let's say we have these 4 elements, that is hello, everybody, let's, and learn. So your first task is to save these elements as a list, a tuple, a set, and a dictionary. Now, next, add another element, which is insertion, to your data structure, whichever you're using. So your updated data structure should be this right here. So try this as a list, tuple, set, and dictionary. Insert a new element, and we'll discuss the solution in the next video. Best of luck.